Hello and welcome to my channel CEB. Today we will construct Moore and Mealy machine to convert each occurrence of 100 by 101. Now first of all we should know what is our input alphabet. From the question it mentioned that it consists of either 0 or 1 because 100 is nothing but the binary number system. So that means our number consists of 0 or 1. That is our binary input symbol. Now what will be the output? Again the output consists of 1s and 0 which is again the binary output. So what we are going to do? We will start reading the input and generate the output. That means we are going to generate the binary input symbols. For the input 0, output will be 0. For input 1, output will be 1. For input 0, 0. Output will be 0, 0. For 0, 1, output will be 0, 1. For 1, 0, output will be 1, 0. For 1, 1, output will be 1, 1. So everything will be okay till we are going to get our targeted string. The targeted string here is 100. So whenever we are going to have this kind of string, at that time the last symbol which is 0 has to be replaced by 1. So this is what we have find out some kind of algorithm. Now what we are going to do? We will trace out. We will write it down in steps. So what I will do? We will start with the initial state Q0. So let Q0 be the initial state which is not having any kind of input or any kind of output. So now let us take this in the form of, we can say some space is reserved for writing the input. So this is a small space where I'm going to write the input symbols. Now to take two space for writing the inputs either 0 or 1. So what is that initial state? Initial state is 0, Q0, in which where we are going to consider the input symbol. Now from the initial state Q0, we will take for example input 0 because we are going to generate the binary input symbol. So let us take the input symbol 0. Now for this input symbol 0, what is the output? The output is 0. So whether we have changed the input symbol to some many output symbols. So here we are writing the output symbol. This is your input symbol. There is no difference between the input symbol and output symbol. So let us give this condition as a new name which is called as the Q1. So this Q1 is the state of input symbol and output symbols are same. Plus this string 0 is not containing any portion of your targeted string. What is our targeted string is 100. So 100, the first position is consists of 1, whether here the first position consists of 0. So this Q1 is not containing any percentage of our targeted string. So this is called as the rejected state, which contains 0% of the targeted string. Now, here we are having, let us take that input symbol 1. So here again we are having Q0 where we are going to consider, because we are considering input symbol 0. Now we are going to consider the input symbol 1. This is your initial position and we are going to read the next symbol as 1. So what will be the output of 1? Output of 1 we had already discussed that there is no change in the output symbol. So if we are having input as 1, here I am going to write output. So here if the input is 1, I'm writing the output. So what is the case? It consists of somewhat requirement of the targeted string. So this your targeted string should start with 1 and my string which is input string 1 is also containing the first position as 1. So this is the case. It contains 33% of the required string. So let us give this condition as a new name which is called as Q2. So Q2, what is the Q2 in which the current string is 0, current string is 1 and the output is 1. So this condition is known by Q2 which is called as the resultant state. So here this is your initial state Q0 with the input symbol 1. It is generating the output 1. Here the input symbol and output symbol are not different, they are same. That was the case in string 0, but here this string 1 contains some portion of the targeted string. Let us say that it contains 33% of the targeted state. That's why we are giving this name, this condition as a new name which is called as Q2. Now we are having two state as Q1. This is our Q1, which is the input symbol 0 is generating the same output symbol but not containing any percent of the required string. And we are having second resultant state as Q2, which is having input symbol 1 and generating the output 1. So this condition, these two state now we are going to consider. So here we have I have considered Q1 with the two input symbol either 0 or either symbol 0 or 1. So let me write it down. This is Q1 state. So what is the Q1 state? I can find out from your previous thing step. That's what is Q1. Q1 is the state that is considering the input symbol 0. So Q1 is representing input string 0. So let me write it down in one space. This is the input string 0, which is known by the name Q1. So Q1 is known as a name. Q1 is a current state now having the input symbol 0. Now, as we are having the binary number system, the next symbol can be either 0, it can be either 1. If it is 0, so this is your previous 0 and this is your next 0. So after writing these two bits together, the newly created string is 00, whether it contained any percentage of your targeted string. What is our targeted string is 100, which is started with 1 and having 0. Here it is not having any match. If it was started with 1 and then having 0, it is going to contain 66% of your solution. But your previously itself, the first bit was not having 1. So this is not containing any percentage of the required string, that is 100. So this is your rejected string and it is indicated by the state Q1. Now we are having next bit, that means this is your previous state Q0, Q1 with the next bit as 1 is generating 0, 1. What will be the output of this one? The output of this one will be 1. The output of this one, if the input is 1 and the output is 1, this condition we had already represented by the state Q2, where the input was 1 and the output is 1, which contain 33% of the solution as indicated by the state name Q2. So whenever we are having 1 in our string, 0, 1 is nothing but 1, which is going to produce output as 1. So the resultant state will be Q2. Now what we are going to consider? We are going to consider resultant state Q2. What is the resultant state Q2? Which string was represented by Q2? The string which was represented by Q2 is string 1. So what I am going to do? We are going to consider the string 1. So string 1, this is represented by the name Q2. So Q2 is now the current state. Now Q2, as we are considering binary number system, the next bit can be 0. And again, as we are having two binary number symbols, we are going to write Q2 twice for considering both the input symbols. So this is Q2, this is Q2 representing 1 with the next bit as 0. Having the next bit as 0, if you are going to compare with the targeted string, it contains 66% of your solution. So out of 100, we are having 10. We can say that in short. So it contains 66% of your solution, which is represented by the new, we can say the state name as Q3. So what will be the output of this bit? The output of this bit will be 0. So we will have the question that if we are having 0 and output is 0, so why we are not indicating that by Q1? Because the Q1 was the rejected state which is not containing any percentage of the targeted string 100. Now here we are having Q3 whose previous bit is 1. After adding one more bit as 0, it is generating 66% of your required string 100. So this is 10, whereas Q1 was 0 only. So that is a huge difference between Q1 state and the Q3 state. Although the output symbols are same here, 0 with the output symbol is 0, but the condition is different. This is the string 10 and this was the string 0. That's why Q1 was considered as the fully rejected string, whereas we can say Q3 is partially rejected string. So Q3 is a partially rejected string. Now this is again Q2 having the string 1 with the next input symbol as 1, generating the string as 1, 1. Now we are going to compare 1, 1 with 100. After this 1, we are having this bit as 1, but the next bit is 0. So it is going to contain only the first portion of your required string, that is contain 33% of the required string. So if we are having next bit as 1, is going to generate output as 1. So which state was generating output as 1 if the input was 1? It was Q2. That's why now the resultant state will be Q2 only. Now, which is the newly created state? The newly created state is Q3. Q3 represent which string? Q3 represent Q10. Now, as we are having binary number system, now this Q3 has to be considered twice, one with 0, another with number system, number 1. So this Q3 with the next alphabet, the next input symbol as 0 is making our targeted string. So now we are having 100, which is our targeted string. So this is our targeted string. But now what we have to do, we have to write the output symbol here also. So if we are having 100, which is the targeted string, the output should be the last bit, which is 0, has to be converted to 1. So here the output symbol has to be now 1. So this is what your output is 1. So this is your input symbol 0. Now change to 1, and this is what the target is string. So this condition is now represented by one state which is called as Q4. Now we are having Q3 state. This is your Q3 state with the next bit as 1. With the next bit as 1, that means it contains only the first portion of your targeted string, which is the 33%. So what will be the resultant state? Resultant state will be Q1, which contain only symbol 1. That is, I think, sorry, that is Q2. So if you are having input as 1, as compared to your targeted string, so it contains only the 33% of the required string, which is indicated by the state Q2, resulting in the number as 1. So this is your Q2, which is your resultant state. Now I will consider the newly created state, that is Q4. So what was Q4? Q4 was your targeted string and whose output was 1. So this is your Q4. How many times we have to consider Q4? As we are having two binary number, that is 0 and 1, we have to consider it twice. One with the input symbol 0. With the input symbol 0, we are going to now declare the previous string, and now we have to consider with this last bit. Last bit is containing only 0. The only 0 means contains 0% of your required string, which is indicated by the Q1 state generating the output symbol as 0. Now the next bit, Q4 with the next bit as 1. So that contains only the, we can say, the 33% of the required string, which is indicated by Q2, whose output will be 1. Now we have to check whether any new state is generated. That we have to consider. We have consider all the symbols 0 and 1 with all the resultant state. So now what we do, we are going to create the, we are going to design the table. So how many tables we have to design? For Moore machine, only one table we are going to design that contain the output symbol. So how many inputs we are having? Two input symbols 0 and 1, and this is the notation for writing the output symbol. Now we start with Q0. Q0 was the initial condition which was reading positions, not reading any input, not generating any output. So here we are going to write the output associated with this state. So Q0 is not having any output, we will put dash here. So Q0 on 0 was going to Q1. So we will go back and check Q0, which was the initial condition. So Q0 on 0, where it is going? Q0 on 0, it is going to Q1. And what is the output associated to Q1 is 0. So we have to write that. So Q0 on 0 is going to Q1. Now this is Q1. So first of all, what we can do for easy understanding, what we can write, we will consider this Q1, and here we are going to write the output symbol of Q1. The output of Q1 was 0. Okay. Now Q0 on 1, where it is going? Q0 on 1 was going to Q2. So because it is containing the 33% of your target string. What was the output of Q2? The output of Q2 is 1. So that we have to write here. So Q0 on 1 is going to Q2. And what is the output of Q2? That we have to mention here. The output of Q2 is 1. Now Q1 on 0, where it is going? So Q1 on 0, it is going to, here it is. So Q1 on 0 with the next bit as 0 is going to Q1 only, and the Q1 with the next bit as 1 is going to Q2. So that way to note it down. So Q1 on 0 is going to Q1 and 1 it is going to Q2. Now Q2 on 0 it was going to Q3 because contain the 66% of your solution. So where it is Q2, this is for Q2 with the next bit as 0 is going to Q3 with the output symbol as 0. So Q2 on 0 is going to Q3. Now this is now new state Q3, so I have to write the output symbol as 0. Okay. Now Q2 with 1, Q2 with 1, where it is going? This is our Q2 with the next symbol as 1. It is going to Q2. It is going to Q2. Now we are having new state Q3, where it is going Q3. This is our Q3. So this is our Q3 with the next input as 0, where it is going Q4, generating Q4 with the output 1. So Q3 on 0 going to Q4, Q4 is generating output 1. So we can write output 1 here. Now Q3 with 1. So this is your Q3 with the next input 1. It is going to Q2, generating the output 1 that we had already considered Q2 state. Okay, now Q4 with 0. So this is your Q4 with the next bit as 0, generating resultant state as Q1. Now Q4 with the next bit as 1, it is going to Q2 state. So we will write it down here. So here we have drawn the table for Moore machine. Now we have to draw the state transition diagram for Moore machine. So how will we start? We will start with the initial state. Initial state is 0, Q0. What was the output? Output is nothing. When we put slash here, we write it down. We have to write down the output of that state. So Q0 is not having any output. We will put dash here. The Q0 on 0 is going to Q1. So on 0 it is going to Q1 state. Before writing the state, we have to note down the output symbol also. So output of Q1 is 0. So we'll put slash and write down. We have to note down the output. Now Q0 on 1 is going to Q2. So on 1 on the transition we have to write input symbol. On the inside the state we have to write the output also. What is the output of Q2? Output of Q2 is 1. So we have to note down the output 1. Now we have to consider Q1. Q1 on 1 is on 0 is going to Q1 only. On 1 it is going to Q2. Now Q2 on 0 it is going to Q3. What is the output of Q3? Before writing the state, we have to note down the output also, put slash and note down the output of Q3 state. Now Q3 on 0. So Q2 on 0 going to Q3, Q2 on 1 is going to itself. Now we will consider Q3. Q3 with 0 is going to Q4. What is the output of Q4? So output of Q4 is 1. Okay. Now Q3 on 0 is going on, sorry, Q3 on 1 is going to Q2. Now Q4 on 0 is going to Q1 and on 1 it is going to Q2. So this is your transition diagram for Moore machine. Now we will design diagram and table for the Mealy machine. So how we are going to draw the diagram and table for Mealy machine? It's very simple. What we have to do, for for Mealy machine, we have to design two table STF, that is input on the state. Input on the state is generating the resultant state S and MAF function in which the input on the state is generating the output symbol which is O. So let us design it. For that, what we are going to do, simply we are going to copy the table that we have designed in Moore machine. So how much table we have to we have to copy? We have to copy everything except the output symbol. So this table is going to copy. This first portion will be copied here. So Q0 on 0 is going to Q1 and on 1 it is going to Q2. Q1 on 0 it is going to Q1 and on 1 it is going to Q2. Q2 on 0 going to Q3, on 1 is going to Q2. Q3 on 0 going to Q4 and on 1 is going to Q2. Q4 on 0 it is going to Q1 and on 1 it is going to Q2. Now what about this table? What are you going to do? Simply we have to note down the output associated with your state. So we are having Q0 here. What is the output of Q1? Output of Q1 from here we will copy. Output of Q1 is 0. So wherever we are having Q1, that we have to write 0. So here we are having Q1 and here also we are having Q1 for Q1. Now we are having Q2. So what is the output of Q2? Output of Q2 is written here, that is 1. So wherever we are having Q2, there we have to write 1. Okay. So here Q2 table, Q2 row also we are having Q2, so that we have to write 1. In Q3 row also we are having Q2, that we have to write 1. In Q4 also we are having Q2, that we are going to write 1. Now what is remaining? Q2 on 0 is going to Q3. What is the output associated with Q3 is 0, so that we have to write here. Wherever we are having Q3, that we have to write 0. So here only once we are having Q3. Now Q3 on 0 is going to Q4. What is the output of Q4 is 1. So wherever we are having Q4, that there we have to write 1. Now Q4 on 0 is going to Q1. What is the output of Q1 is 0, that we have to write. So the table is now completed. Now what is the next step? The next step is we have to draw the state transition diagram. So for that, what we're going to do, we will start with the initial state, that is your Q0. So here we have to write input and output symbol on the transition. So Q0 on 0, that is going, it is going to Q1. What is the output of Q1 is 0, so that we have to write here. Now Q0 on 1, it is going to Q2. What is the output of Q2 is 1, that we have to write here. Now Q1 on 0 is going to Q0 with the output 0. Q1 on 1, it is going to Q2 with the output 1. Now Q2 on 0 is going to Q3. What is the output of Q3? It is 0, so that we have to write here. Now Q2 on 1 is going to itself with the output 1. Now Q3 on 0 is going to Q4. What is the output of Q4? So that we have to write on the transition. What was the output of Q4? Yes, output of Q4 is 1, so that we have to write here. Now Q3 on 1, it is going to Q2 with the output 1. Now Q4 on 0 going to Q1 with the output 0. And Q4 on 1, it is going to Q2 with the output 1. The diagram of Mealy machine, transition diagram, and both the tables are similar to FSM. So what we have to do, we have to design, if you have already designed FSM, so what we can do, it is very easy to design Mealy machine. Hope people have understood the concept of converting 100 by 101. Do like the video, share the video, and subscribe the channel. Thank you.